Hi everyone, today we're going to dive into an exciting topic that lies at the heart of computers and digital devices, number systems. By the end of this lesson, we're going to understand key number systems used in computing. So what is a number system? A number system is a way to represent numbers. While we use something called the decimal system every day, computers use number systems like binary, octal, and hexadecimal. So let's get into the decimal system first. The decimal system is what we use in daily life. It is base 10, and it has digits 0, 1, 2, 3, 4, 5, 6, until 9. Okay? All the numbers from 0 to 9. Each position in the decimal number represents a power of 10 based on the place value it's at. Okay, so let me show you an example of one. So let's say the number 246, and this is going to be in base 10, which means decimal. Each of these can be broken down into a place value, into a power of 10. So we see 2 times 10 to the 2, plus 5 times 10 to the 1, plus 4 times 10 to the 0. We'll see when we multiply and do the powers here. Times 10 plus 4 times 1. This eventually, when we add all this up, equals 254, which is what we see here. So we see 254 in base 10 can be broken down into these powers. We'll see how this is relevant in the other number systems. So let's look into binary now. This is the language of computers. So sometimes you'll hear people say computers talk with 2 digits, 0 and 1, right? So binary is the language of computers, and it only uses 2 digits, zeros and ones. Binary is base 2, and each number within a binary number can be broken down, and each position represents a power of 2. So let's break down this binary number as an example. 10112. The 2 below just represents that it's base 2, that is in binary. Okay? So let's break this down. This one is going to be 2 to the power of 3 because it's at the 3rd position. Plus this 0 is going to be 2 to the power of 2. It's at the 2nd position there. 1 times 2 to the power of 1 plus 1 times 2 to the power of 0. When we multiply this out, 8 plus 0 plus 2 plus 1. So we'll see that this number 1011 in binary is 11 in decimal. Okay, let's move on to octal, which is the next number system. Octal uses 8 digits. It is base 8. It uses digits 0, 1, 2, 3, all the way until 7. Each position in an octal number represents a power of 8. Okay, so let's try this number and see how it breaks down. 1 and 7 in octal. Okay, so 1 is in that first position, so we're going to do 8 to the power of 1 plus 7 times 8 to the power of 0. Over here, you have 1 times 8, which is 8, plus 7 times 1, which is 7, but when we add it together, it's going to be 15 here. Okay, so 1, 7 in octal is actually 15 in decimal. Okay, and this is where it gets a little bit tricky here. So now we're going to talk about hexadecimal numbers. Hexadecimal numbers are base 16. Hexa meaning 6 and decimal meaning 10. Okay, so over here, the digits are a little bit different. It uses symbols and the numbers from 0, 5, 6, 7, 8, 9. And then it actually uses letters. It uses the letters A, B, C, D, E, and F. And A here symbolizes 10. B is 11, C is 12, D is 13, 14, and guess what F is? 15. Okay, so each position here in a hexadecimal number represents a power of 16. So let's try this example with 1F. This is going to be in base 16, which means it's hexadecimal. Let's break this down into powers of 16. We have 1 times 16 to the power of 1 plus F times 16 to the power of 0. We have 1 times 16 here plus, what is F? F is 15. 15 times 1. Okay, we have 16 plus 15, which is equal to 31. This is in decimal. So 1F in 1F in hexadecimal is actually 31 in decimal. Okay, cool. So those are the number systems that we're going to talk about today. Thanks for watching.